Okay, so we'll continue on here. I've posted homework 2 as well. You can start to take a look. A lot of it is it's programming, writing functions and things like that. And so so we'll get into that today. Today I'm going to just kind of wrap up some of the topics on subsetting, and then we'll get into some flow control here. Okay, so let's take a look at some applications of subsetting. Okay, and all right, so let's do this. Okay, so you can create what we call a lookup table. Okay, and because with subsetting, if you call the same index multiple times, it's going to return the same result multiple times. Okay, and so we can take advantage of that and create a lookup table. All right, and so I don't know, maybe you guys have used VLOOKUP in Excel or something like that. It's kind of like that, except in my opinion, it's very simple to implement. Okay, so here I've got a vector of m's and f's. Okay, and a u. And over here we create a lookup table, and we say if you see M, that means male, if you see F, that means female, and if you say U, it's going to be either undefined or missing or something like that. Okay, and then so what we're going to do is we're going to take lookup and we're going to subset lookup, which really only has 3 items in it, but we're going to subset it using this vector with 6 or however many there are, 7 things in there. Okay, and so because it sees M multiple times, every time it sees an M, it's going to pull from lookup the word male, and every time it sees the F, it's going to pull the word female. Okay, and so the lookup, the important thing is that you've named each of these terms there. And then if you just want to do this, you can run it through the command unname, and it strips out the things that it used. All right. Okay. Or and if you didn't want to and with the lookup table, you can have multiple names refer to the same thing. So for example, we could say M is going to go to known, F is going to go to known, and U is going to go to unknown. Okay, and then it's no problem that that we're using known, even though it's being pulled from the M and the F. Okay, is that all right? So it's a very useful thing if you need to. It's kind of like find and replace, right? Like find each of these things and replace it with this. We can just kind of take advantage of the way R uses its subsetting feature, right? We don't think of replacing all the M's and F's with males and females as a feature of subsetting, but it is. We are subsetting this named vector, which only has kind of like 2 entries, and we're taking advantage of this featuring. Okay. All right. Over here, we might have some kind of complicated lookup table which has multiple columns of information, and so here maybe we have a vector of integer grades, like 1, 2, 3. We're grading on an integer scale. All right. And so 1 would be poor, 2 would be good, and 3 would be excellent. So from here we're creating a data frame where let me just show you what the this data frame would look like. Okay, so if we look at the data frame info, it looks like this. Okay, 3, 3, 2, 1, excellent, good, poor, and then as far as the fail term goes, the top 2, they are not fails, but the poor is a fail. Okay, and then so we can subset the info using the grades and this match feature. Okay, so so let me just show you what we have. Okay, so as far as match goes, okay, let me just show you how match works. We're going to match the grades, which are, you know, this vector of 1, 2, 2, 3, 1, and we're going to try to match it into info $grade, so just this column. Okay, and then so match basically says the ID that we're going to use is going to be pull from row 3, pull from row 2, row 2, row 1, row 3. Okay. Because notice that the row names are 1, 2, 3s, whereas the grades go in 3, 2, 1. So if I try to match on the row name and I look at grades, right? If I pull the first row for this, it's going to say this is actually an excellent. So using match, it's going to return back the row ID of the corresponding thing. If that makes sense. In this simple example, it's really just swap the 1s and the 3s, but in a more complicated one, you know, the thing that you want to look up, you would use match to get the row number that corresponds to it. Okay, and then so match produces these basically row IDs, and then if we subset info based on those IDs, okay, we can pull up the grades, right? So looking up the original vector of grades, which was 1, 2, 2, 3, 1, we see indeed it goes 1, 2, 2, 3, 1. Okay, and then we can ignore the row names because it's trying to give each row a unique name, but it really has nothing to do with anything here. Okay. All right. The other way we can do this, all right, is we can change the row names to match the thing that we're going to use to grade. Okay, that we want to grade on, right? So here, the previous method was we said we're going to try to match the vector of grades to this column info grade. Okay, over here we're just going to say, you know, this is the column that we're going to use to match. Let's turn that into row names. Okay, and then so I can do this. I can say row names info is that column info $grade, and so if I look at info, now the row names match this column grades. Okay, and then I can subset using info by switching grades into character, because row names are character vectors. Okay, and then so we match it based on that. Okay, and so we're essentially creating, it's the same idea of a lookup table as in the previous example, but here we're applying it to a matrix that has multiple columns to it. Oh, you know what? I'm sorry, I forgot. Make my text bigger. Okay, so there you go. Is that good? What's that? The 2.1 and 3.1. So why are we getting 2.1 and 1.1 and all of this nonsense stuff? So here we are subsetting info, which is a data frame, based on this vector of grades, right? And essentially, what all it's doing is it's just repeating. Every time it sees the value 2, it's going to pull the second row, okay? And because we're pulling the value 2 twice, it's repeating the second row twice. And R has this default, in its default settings, which is probably a good thing, is that it wants to create unique row names when it does that, okay? And then so because we're pulling the same row twice, in order to distinguish the second row from the first row, it appends it with a .1, okay? And if I pulled it a third time, it would have 2.2, okay, and so on and so forth. So these row names here, after you've subset, really don't mean anything. You can just get rid of them, and you would not be losing anything. So it's just something that happens. Okay. So that works. Okay, and okay, and then yeah, don't worry about this. You know, maybe you want to, I don't know, try to match on multiple columns. You'll then have to kind of collapse them together into a single column that you can use to identify on. Okay, and then we can create random samples in a very similar way. All right, so let me. So later on we'll look at bootstrapping, and this is one way to do it. Okay, so here I'm going to create a data frame. Okay, and so let's look at what our data frame is. Okay, the data frame has 6 rows, and an X, it's just 1 1 2 2 3 3. Y is 6 5 4 3 2 1, and Z is A B C D. Okay, so this is nothing. This is just like fake data. It doesn't really mean anything. Okay, and so set seed. Okay, just so everybody gets the same thing. So let me just show you what sample n row df does. Okay, so effectively, right, I have 6 rows in df, so it's really, I'm just doing sample 6. Okay, what do you guys know what sample 6 does? Okay, sample 6 is going to take the numbers 1 2 3 4 5 6, and it's just going to rearrange them. Okay, it's just take the digits 1 through 6 and then rearrange them. And so if I did sample 6 again, it just shuffles each of these numbers. Okay, so if I did seed 10, this is what it's going to get. And so effectively, I'm just taking this row, the rows in df, and I'm just shuffling them around. Okay, and they'll be shuffled around 4 2 5 3 1 6, because that's what we have. Okay, and so all we did was we just shuffled those rows for 4 2 5 3 1 6, and this is our new shuffled data frame. Okay, so you know, if you have like a quote a deck of cards and you need to shuffle them, this is one way to do it. Okay. This is effectively sample 6 comma 3, so it just says take out of the numbers 1 through 6, give me 3 of them, and I think that will give us effectively 263. Okay, so effectively it just, so when I ran sample 6 the second time after set seed 10, the first 3 numbers were 263, and so that's what we get, 263 here. All right, and so as far as sampling goes, is it just takes your thing and it shuffles them around. Okay, if there's an option for sample which is replace equals true, which says you know, from the numbers 1 through 6, pick a number at random. Okay, and then put that back in there. All right, and then take a number at random from 1 through 6. And so sample 6 with replace equals true means that some of the items will get selected more than once, and others won't get selected at all. Okay, possibly. Okay, it is also possible from random chance that everything gets selected, but probably unlikely. Okay, so just from random sampling, the number 4 happened to get selected 3 times, and the number 3 got selected twice. Right, so this is just rolling a die 6 times, because that's with replacement. Okay, it's not like once you roll a 4 you can't get a 4 again. All right, otherwise that would make Yahtzee very easy. Right, okay. All right, and then with ordering, you take a Vectorize input, and it returns an integer vector describing how the subsetted vector should be ordered. Okay, so this seems silly because it's like, oh, we might as well just do sort, but you know, here we're giving it BCA, and we're saying order that, and it's going to say, okay, if you want to put that in order, first you do 3, then you do 1, and then you do 2. Okay, so If we feed that into itself, we get x subsetted by the order of x. It's going to put that in order, A, B, C. Okay. And then if you want to switch it into reverse ordering, you can do decrease equals true by all of that. Okay. Missing vectors are put at the end of the vector, or you can put them at the front with na.last equals false. Yeah.
What's the difference between sort and order?
So sort just puts them in order. Order tells you the index that you need to use to put the things in order. Okay, so for example, so let me just do sample letters 1 through 6. Okay, whoops. And we'll call this A. Alright, so A is this, alright? So it's the C, A, B, D, F, E. Okay, sort of A. Okay, sort, we'll take the vector and then just put them in order. Okay, so when you get sort back, you're going to get a vector of the same original type put in order. Okay, order of A will tell you if you want to put A in order, first go to the second item, then go to the third item, then go to the first item, then go to the fourth, then go to the fifth, and then the sixth. Okay, or whatever it's, then the sixth and then the fifth, or something like that. Okay, so so there's a few ways, you know, if you want, you can do sort A. All right, let's say you want the third highest thing. Okay, sort A 3. This will tell us, okay, the thing ranked third is C. Okay, if you want to find out which index that is, you can do order of A 3, and it will say the third place thing is in the first position. Okay, I know if it feels weird, but so it's saying in A, in the first position is the third place thing. So it's they're very similar, but they are definitely different. Okay, so anyway, if you wanted to reorder a data frame based on one of the columns, this is where order can be helpful. Okay, so you can do so. All right, so let's just show you this. So here I'm creating data frame 2, which is just a shuffled version of the data frame. Okay, so this is all jumbled up now. Okay, and now I want to arrange them on column X. Okay, so I'm going to go df2 $X. All right, it's this, and I'm going to say, okay, put this in order. And right now there's no thing for ties. Okay, it just says, okay, go to the third, go to the sixth, then go to the first, and then the fifth, and then go to the second and the fourth. Okay, it's not. It doesn't quite know that there's other columns to look at for the ties, and so when we do this, it does indeed arrange it by X into 1, 2, 3. But then we look at B and we notice, oh, this is not quite A, B, C, D, E, F. Okay. I can take the names of DF2, which are the column names, right? Okay, and I want to put those in order. Okay, then what this will do, so DF2 is still the messed up ordering, right? But at least now if I use this, then it will put the columns back in order from X, Y, Z. Okay. Okay. So here we have a column collapsed. So you might have something where they've said the letter F shows up 6 times or something like that. if you need to expand that back out, you can use kind of it's funny to think of it as subsetting, but it's a way to do it. Okay, so for example, let's let me just show you what df looks like. Okay, so we have this, and what we're going to do is we're going to, so here this basically says you know, this value 2,9 shows up 3 times, 4,11 shows up 5 times, and 1,6 shows up 1 time. Okay, that's what the df represents. Okay, so here we have the n column, which says this item shows up 3 times. Okay, and then so what we're going to do is we're going to repeat the 1 through 3. Okay, repeat 1 through 3, and the number of times we repeat them is going to be based on this column n. Okay, and so basically it just says take 1, repeat it 3 times, take 2, repeat it 5 times, take 3, and repeat it once. That's what this little command does. Okay, and then so I'm going to feed that back into df, this exact thing, 1, 1, 1, 2, 2, 2, 2, 2, and 3. Feed that back into df, and now now I have expanded out the this thing. Okay, and I should probably get rid of the n column now that I've done that. Okay, but now we can see I have 2,9 showing up 3 times, 4,11 showing up 5 times, and 1,6 showing up once. Okay, all right. 2 ways to remove columns from a data frame. You can set individual columns to null. You can just say, so here's data frame, and you can just say df $z is null, and then boom, data frame now has just lost that. Okay, or this is probably the method that I use the most, is just, okay, I just want columns x and y, and then it returns back that. Okay. So here, so you can set a column to null, or you can just say subset df, giving me just the columns that I want. Okay, and all right, and then lastly, it says if you know the columns you don't want, you can use set operations to work out which columns to keep. Okay, and this is using the set operation set diff. I don't know if you guys are familiar with that. Okay, so if we go to names df, names of the data frame, we have x, y, z. Okay, and then set diff is basically from this thing x, y, z. Tell me which ones are different from the thing I give it. Okay, so set diff this basically. Here it says from x, y, z, tell me which ones are different from z, and it'll tell you that's x and y, right? I can also say, like, give it, you know, a and z, and it will not complain. It'll just, whoops, it will just say the ones that are different between these two are, you know, x and y. All right, so you can look up your set operations, and this is like, you know, which ones are intersect and the different and things like that. Okay, so all right. And then so we'll cover a lot of this stuff when we use dplyr, which has its similar things. But you know, I think we've seen this already. We've said, you know, if you want to just filter out certain rows, you can just say, okay, give me back the rows, because empty cars $gear equal 5 is going to be a true-false vector for where gear is equal to 5. Okay. And so it gives you the true falses, and when you feed that back into the data frame, it'll only return the rows where this is true. Okay. and then you can combine those things. You can have multiple true and false things. So you can have gears equal to 5 and cylinders must equal 4, and it will return only the rows where both of those things are true. Okay, and that's using the AND. All right. You can also use the vertical bar for OR. Okay, and then it will give you back the rows where one of those things is true. Okay. We do have in R we have the double AND and the double OR. Okay. The double AND is double AND and double OR are reserved for if statements, okay? Because if statements can only accept one thing at a time, whereas single AND and single OR are vectorized, okay? So if you give it, you know, a vector of 10 true falses and another vector of 10 true falses, it will match them pairwise, okay? Or element-wise. So most of the time you'll just use these. Only in if statements use the double AND or the double OR, okay? And then you guys remember De Morgan's law from probability and all of that stuff, right? And all of those Venn diagrams, and so don't worry. Okay, and then subset is it's a special function. It's just kind of like rather than having to write this, give me empty cars where empty cars $gear is equal to 5, you can just say subset empty cars gear equal to 5, and it does the same thing. Okay, so it's a shorthand method. Okay. All right, so we have set operations, which subsets using integers, and then Boolean algebra, which is the logical subsetting, and you know, when do you want it? Okay, so set operations being like, give me the rows, you know, 1 through 6 and things like that, or you know, the columns X, Y, and Z, and all of that. So set operations are more effective when you want to find the first or the last true. Okay. Or you have very few trues and very many falses, okay? And it might be easier that way. You know, I think some of it will probably develop our own preference for the way we subset things. Just over time, I probably favor Boolean algebra, using the trues and falses to figure out which columns I want and things like that. But R accepts either of those. So, you know, when I write code, you'll probably have a tendency for me to write all of these true, false, and or statements. But set operations totally work. Okay. And then which takes converts a Boolean representation to an integer representation. Okay. So here, if you have trues and falses in Boolean, you can turn it into integer representation using which, okay, and it will tell you which. So if you feed a logical vector into X, which is going to tell you the ones that are true. Okay. So here, you know, I've got false, true, true, false, 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 true, which will say, oh, the second, the third, and the 10th, those are the ones that are true. Okay, I guess we'll work through this. All right, so you know, here we're going to create two logical vectors and their integer equivalents, and then explore the relationship between Boolean and set operations. All right, so here I've got x1 being the integers 1 through 10, where mod 2 is equal to 0. So this is basically just the even numbers, right? But we're turning that into trues and falses. So I got false, true, false, true, false, true, false, true, false, true. Okay. So here I've got basically the ones in the even positions are true. All right. So over here, if I do which x1, it's going to give me back the even integers, 2, 4, 6, 8, 10. Okay. Over here, I've got the ones that are divisible by 5. Okay. So I got false, 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 true, false, 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 true. All right. And if I ask which ones of y, I get 5 and 10. Okay, so x2 is the even integers, y2 are 5 and 10, okay, and then x1 and y1 are they're equivalent logical vectors. All right.
Is
So
which returning the position in which they are, or the values?
the position, okay? But I mean, so nowhere do we actually have the values. Yeah, so it returns the positions of these things, okay? All right, so if I do x and y, all right, this will be the and, right? So the only thing it's, false, this thing of false and trues, and then this thing of false and trues, the only thing that that returns true will be this last one, okay? And if I did a which on this, it would give me 10, okay? Here, over here with set operations, I can say the intersection of x2 and y2 is going to be 10. Okay? Over here, if I do the or, it'll give me all of these things, okay? And that would be equivalent for doing the union with this, okay? So it'll give me all 2, 4, 6, 8, 10, and then 5, okay? And so it's basically running which on this and which on this will also give us these things, okay? All right. X and not y, this is set difference between x and y, okay? So so we're turning the x1 is the true false for the evens, okay? And then y1 was the true falses for divisible by 5, right? So not divisible by 5 is now everything that's not divisible by 5, okay? And then when we do those, then that 10 becomes a false, and we see that those will be 2, 4, 6, 8. So the set difference x and y is x and not y is set difference there, okay? All right, and over here, this is the one that like messes you up. Okay, this is the exclusive or. Okay, are you guys familiar with exclusive or? All right, so some of you are. Exclusive or. This is in English we have inclusive or and exclusive or, but we just use the word or, and that's why it gets confusing, right? Because I could say, do you like chocolate or vanilla ice cream? And your answer would be yes or no, okay? That's the inclusive or, okay? Now, on the other hand, I could say, do you like chocolate or vanilla ice cream? Okay, same exact words, but now suddenly your answer is, oh, I like chocolate, or I like vanilla, okay? And that's the exclusive or. It's one or the other, but not both, okay? And so, this is, it's kind of funny, but you can just say XOR on the true false exclusive or, and that will give us only trues where it's one is if it's a true, only one side can be true, okay? So if both are false, it'll return false. If one is true and the other is false, then it will return true. But if both are true, it will return false, okay? So it will give us a true for the 2, a 4, where did this go? Okay. Okay. True for 4, 5, and 6, and 8, but not the 10, okay? For divisible by 2 and divisible by 5, all right? And then so if you, in order to replicate that using set operations, you have to say what's the difference between the union and the intersection, okay? And that will return you, 2, 4, 5, 6, 8, okay? Okay, so it says, when first learning subsetting, a common mistake is to use x bracket which y instead of x bracket y. And here, the which achieves nothing. It switches from logical to integer subsetting, but the result will be exactly the same. Also beware that x negative which y is not equivalent to x exclamation y, okay? If y is all false, which y will return integer 0, and negative integer 0 is still integer 0, so you'll get no values, right? Instead of all the values. All right. So that was all the subsetting stuff. Yeah, correct. Okay. All right. So programming basics. Okay. You should always use a working directory. Okay. Set your working directory. You know, our studio has a feature for projects which kind of creates its own directory, its own working directory for a project. I didn't put that in here, but it's also a handy thing. You can, you know, when you start working on a homework assignment or something, you can create a new project in R, and it'll create a folder for homework 2 or homework 3, and it'll keep all the relevant files there. And then when you load up the project, it will automatically set that thing as the working directory, and all the stuff that you want for it will be in there. Okay, so RStudio, Lookup projects, it's a good thing. Okay, generally you can also just do get work directory or set work directory. You can use the menu interface, or you can write it somewhere in your document, and just if you're on a PC or a Windows machine, this is not going to work. You either have to use the / or the double backslash. Okay. Okay, and then comments in your code, you use what do we call this thing? We call it the hash now, right? Or huh?
Hat sign.
The hat sign? Pound sign, right? Pound sign. Something else. Okay, yeah. It used to be like the number button. Yeah, pound. Nobody ever represents pounds this way, but like it's not like you go to the grocery store and they say $2/#3 or £1 or something, but they used to, but they don't, right? And then do you guys know the origin of the word ampersand for the and sign? It used to be you sing through the alphabet ABC XYZ or XYZ, and then they would tack on and per se and, which was to say like per se meaning like and on its own, right? The symbol and, okay, and then but and per se and just because like elemental P became one word type of thing, and per se and became ampersand. So no, whatever. Okay, not that you guys cared, but now you know. All right. Okay, and then so RStudio has like buttons that do this thing. You can just clear your entire environment just by hitting the broom, okay, and then it goes away. Or you can do rm list equals ls, okay, and then when you ask for tell me what's in my workspace ls, it'll say character 0, right, which now we know is a character vector of length 0. It's empty, okay. All right. Okay, you can write a new script. You can do write a new script, or again you can create a new project or open a project. Okay, over here for the projects are over here, and then as you create new scripts, you'll do this stuff in here. Okay, and I think you guys are already familiar with this, right? Like if you want to run commands from here, you just hit Control Enter, or you can click line by line. You just click Run, right? And then here now it's complaining that I'm trying to run my text. But that's all it does, right? You click this button, Run, or you hit Control Enter, and it just takes all of this stuff and it tries to do it. Okay. And then if you want to run the entire script, you just source it. Okay. You can over here, as you're writing your script, you just click Source, okay, and it will load the entire thing, okay. So that's also another shortcut, right? Like you keep writing your stuff, and then when you feel like you've got it good, you just click Source. All right. So we have your Boolean things for logic operators. So you got or, you have and then you have not, and these are all vectorized, so you can throw them into throw vectors of logical things, true false logical vectors Okay, and then these ones, these are non-vectorized. This will only work for the first element in there, and it will only return one true or false. Okay. All right. Okay. Blah blah blah. I think you guys all know that. Right. So over here, true, 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 false, 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 true, false, true. The ORs will do that, whereas the double OR will only look at the first thing. Okay. Double AND only looks at the first one. Okay, and then exclusive OR, I think we already talked about that, and then is true. This is only going to work, is true works only if it is a length 1 logical vector whose only element is true and has no attribute names, no attributes, okay? So is it really just the object true? Okay, is true. It's a very strict thing. Okay, it's basically is X identical to the object true. Okay. Now why would we want that? You know, sometimes it's useful. Okay, and then comparisons. All of these things are vectorized. You know, less than, greater than, less than or equal to. Are they equal and not equal to? Okay. Just watch out for double equals. We'll talk about numeric precision, okay? But all right, what happens if I do +1 plus 0.2? What's R going to return? Not a trick question. It's 0.3, right? Okay. So let me just store that as X, right? And then I can do is X equal to 0.3. What's this going to return? False. Oh, what's going on? Okay, so the thing is that this is true, okay? But and you think X is and X looks like 0.3, but it's not, and it's because and we'll talk about this later, but because of the way R represents numbers, or a computer stores numbers, these are not exactly equal, okay? It's kind of like, okay, so let's say I told you write the number 1/3 in decimal form, right? You would write 0.3333333333333, okay, or something. In math, we have a little line above that we can write over the last 3 to say like it keeps going forever, but you know, on paper you can't do that, right? And if I said, okay, multiply this thing by 3, I don't know. It's gonna over here. Okay, okay. But if you multiplied it by 3, you'd get like 0.9999999, right? And then we're effectively asking, is this thing equal to 1? Okay. Technically, it's not, right? Even though, you know, in our mind we know, oh, 1/3 times 3 is 1. But okay. Well, anyway, all right. So just be careful when you do these equal things, okay? Yeah. Vectorize. This means can you give it a vector of numbers 1, 2, 3, 4, 5, and another vector of other numbers, you know, 2, 6, 10, whatever, and it will compare them element-wise. It'll go first to first, compare the, you know, is the first element in X less than the first element in Y? Yes or no? Is the second element in X less than the second element in Y? And it will go element by element down the vector. And if it runs out of one, it's going to recycle the other one. Okay, so that's what vectorized means. Okay, whereas other ones, it doesn't know how to do this recycling business. Okay, or element-wise comparisons. All right, and then probably your most important conditional ever in all of programming is the if statement, right? So you say we want to run these commands only if this thing is true, right? So you create an if statement where you put a condition inside. Okay, so you say if parentheses this condition happens to be true, then run the commands that are inside these curly braces. Okay. Otherwise, if this thing is false, skip over all of these curly brace commands and then do the next thing. Okay. And then so if and then you know one thing is that if there's only one expression to execute, then the curly braces are optional. Okay, but generally we put curly braces to say to do this thing. Okay. All right, so we'll say x is 1 and 3. 1 in x, percent in percent is, is the number 1 inside of x true? So we'll say if 1 is in x, print hello, all right? And then because this thing is true, we're going to say hello. Okay, over here, we're going to say x is 1 and 3. X greater than or equal to 2. Okay, that's going to give back false and true, all right? And then because the if statement can only accept one false or true thing, okay? It's only going to look at the first thing in here, and it's going to see the false, and it's not going to print this, okay? And it's going to say, just so you know, you gave me something that has more than one. The logical vector that's supposed to go in your if statement should just be length 1. And it's going to say, you gave me something with length 2, okay? Only the first element is used, okay? So it prints a warning, but it doesn't print hello again, right? And over here we have any. Any is basically it's an or for all of these. So if any of these things are true, return true, right? You can have 20 falses and 1 true. Any, this vector is going to be true, okay? Any will only return false if everything is false. So that's going to be true, and then so this works, and it prints out. Okay. All of these things you can nest them, all right? So you say, if do this, and then we have the else, okay? And then you say do this, and if that's also not true, then else, okay? The important thing is that else has to be on the closing line, on the same line as the closing curly brace, okay? If you don't put else on the same line as the closing curly brace, it doesn't recognize it as being linked to this first if statement. So it's going to execute the if, and then it'll go on and it'll say else what? I don't know what you're talking about. So you always have to make sure that you have this, okay? And then you run that, okay? All right. I guess we'll start talking loops on Monday. Okay.